Okay, so today we are going to solve x squared equals I, and we are going to solve what x is. So note that every complex number can be written in the form a plus bi, where a and b are real numbers, right? A and b are real numbers. Now, if x is a complex number that can be written in the form a plus bi, then x squared will be a plus bi squared, which will by definition equal I. Now, what is a plus bi squared? We can expand this. A plus bi squared is just equal to a plus bi times a plus bi, which we can use the distributive property to say a times a plus bi plus bi times a plus bi. We can expand this further and say a squared plus abi plus abi plus b squared I squared. But of course, I squared by definition is just -1, so you can rewrite this as a squared plus abi plus abi plus -1 b squared, which is just minus b squared. We can combine the like terms abi into a squared plus 2abi minus b squared. Now, note that the first and last terms do not have the variable I, and they're real, and the middle term is imaginary. So we can separate the real and imaginary terms into a squared minus b squared plus 2abi. Now, note that I equals 0 plus 1i, because I is what we're trying to solve, right? So we can say, so we're trying to solve for a plus bi, and more specifically, we're trying to solve for a and b. So we can write a system of equations, right? A squared minus b squared is 0, and 2ab equals 1. And we can do this because a squared minus b squared is the real part, and the real part of I is 0, and 2ab is the imaginary part, which is 1 for I. Now that we can solve this, now that we wrote this, we can now solve it, right? So if a squared minus b squared equals 0, then a squared, we can add b squared to both terms and get a squared equals b squared. We can take the square root of both sides and get a equals plus or minus b. So don't forget the plus or minus. We can now examine the two cases. First is a equals b, and second is a equals negative b. Now, if a equals negative b and 2ab must equal 1, then we can write 2 times negative b times b equals 1. We can write negative 2bb equals 1, or negative 2b squared equals 1. We can divide we can divide negative 2 by both sides and get b squared equals 1 over negative 2, and b squared equals negative 1/2. But if b must be a real number, in which we said here, then b squared must equal a positive number. Because if b is real, then b can either be negative, 0, or positive. If b is positive, then its square must be positive. If b is 0, then its square must be 0. And if b is negative, then its square must also be positive. So if b squared equals negative 1/2, then b cannot be real. So we can disregard a equals negative b because there are no real solutions. Now, how about a equals b? If a equals b, you can say 2a squared equals 1. Therefore, a squared equals 1/2. You can take the square root of both sides and write a equals the square root of 1/2. Or plus or minus, more accurately, a equals plus or minus the square root of 1/2. This means that a equals plus or minus the square root of 1 over the square root of 2, which means that a equals plus or minus 1 over the square root of 2. We can rationalize the denominator, right? Because now that we know what a is, it will be a part of our answer, which means that we will, it'll be best for us to rationalize the denominator. Doing so, we can multiply 1 over the square root of 2 by the square root of 2 over the square root of 2. Which means that the result is plus or minus the square root of 2 over the square root of 2 times the square root of 2, which is just 2. Now, if a equals plus or minus the square root of 2 over 2, and a equals b, then b must also equal the square root of 2 over 2. So I'm just going to write equals b. So we've solved our systems of equations. So we get a comma b equals the square root of 2 over 2 comma the square root of 2 over 2. And also another possible way is negative square root of 2 over 2 comma negative square root of 2 over 2. Now, knowing this, knowing that we already solved the systems of equations, we can write this thing in the form a plus bi. So x equals a, which is the square root of 2 over 2, plus b, which is also the square root of 2 over 2 times I. It can also equal negative the square root of 2 over 2, which is another value for a, and minus the square root of 2 over 2, which is the other value for b, and times I. So this is these are the two possible values for x. Now, to check, we can substitute these values into the original x. For the completely positive, quote-unquote, positive value, we can say the square root of 2 over 2 plus the square root of 2 over 2 I, all squared, equals I. And we can see if this is true or not, because if both sides of the equation align, that is like they're completely the exact same thing, then that means that we got the right answer. So again, we can expand this as the square root of 2 over 2 plus the square root of 2 over 2i times the square root of 2 over 2 plus the square root of 2 over 2i equals I. And then we can use the distributive property. And then using the distributive property, we can write the square root of 2 over 2 times the square root of 2 over 2 plus the square root of 2 over 2i plus the square root of 2 over 2i times the square root of 2 over 2 plus the square root of 2 over 2i equals I. So all of this equals I. And Now we can further use the distributive property and say the square root of 2 over 2 times the square root of 2 over 2 plus the square root of 2 over 2 times the square root of 2 over 2i plus the square root of 2 over 2i times the square root of 2 over 2 plus these last terms, which is the square root of 2 over 2i times the square root of 2 over 2i, and all of this equals I once again. We can actually multiply these together, which means that 2 over 4 plus 2 over 4i plus this is these two multiplied together is 2 over 4, and you multiply it by I, which gives you 2 over 4i. And then the last terms is, of course, 2 over 4i squared, and all of this equals I. Once again, I squared is -1, so we can rewrite this as 2 over 4 plus 2 over 4i plus 2 over 4i minus 2 over 4, because I squared is -1, so we can write plus -1 2 over 4, which is the same as writing minus 2 over 4. And once again, this equals I. Notice that these two terms cancel out, because here is 2 over 4 and here is a -2 over 4. And these two terms, when added together, gives us 4 over 4i equals I. And 4 over 4 is just 1. So I equals I. This is of course correct, which means that the original value for x is correct. But this is the quote-unquote positive value. And now we need to check the quote-unquote negative value. So, checking the negative, we can write negative square root of 2 over 2 minus square root of 2 over 2. Also, you square this term because this represents x, and when you square it, represents x squared equals I. And once again, just like last time, we can use the distributive property. Well, now we're expanding the terms. And now, after expanding the terms, we get negative square root of 2 over 2 minus negative square root of 2 over 2 multiplied by negative square root of 2 over 2 minus the square root of 2 over 2 equals I. So now we can use the distributive property. And of course, it's pretty clear that, which is why I didn't immediately write it, but it's pretty clear that the ending terms is I, right? So now, because I didn't write it because originally I didn't write it because I just wanted to show the expand, how it looks like when it expands. But now, as you can already see, I'll just write it now. And then we can multiply these together, which gives us 4 terms, right? Negative square root of 2 over 2 times negative square root of 2 over 2 minus negative square root of 2 over 2 times square root of 2 over 2i minus, I'll just write it on the bottom, negative square root of 2 over 2i times negative square root of 2 over 2. And then you subtract that by again by negative square root of 2 over 2i times negative square root of 2 over 2i, and all of this equals I. And now we can see that when you have a negative and then you multiply that by another negative, then the result is of course positive, so we can cancel out the negative terms. Alright, and the result is just positive, so now we can write the square root of 2 times the square root of 2 is of course 2, and then you divide that by 2 times 2, which is 4. So 2 over 4 plus, because the minuses, the negative signs specifically, are cancelled. So we can write plus 2 over 4i, and then another plus 2 over 4i. And then you add that again, and then you get 2 over 4i squared, because there are two i's and you multiply by it together. Of course, I squared is just negative 1 by definition. That's how we define I. So we can write minus 2 over 4. And I'll just copy all of this down. Right? And then you can cancel out the 2 over 4 terms and the negative 2 over 4 term. And then you get 2 over 4i plus 2 over 4i equals I. You can write 4 over 4i equals I, which means that I equals I. This is of course true, which means that the original value for x is also true. So we've checked both values and both of these are true. Of course, we can also note that this value is just negative 1 times this value. So let me just write this negative square root of 2 over 2 minus negative square root of 2 over 2 just equals negative 1 times this value, the quote-unquote positive value for x. Right? And if this is true, which we just checked, if the quote-unquote positive value for x is true, then this quote-unquote negative value must also be true, because when we square this, the negative 1 when squared just equals 1. So the result will be 1i, which will just be equal to I. And now we solved x squared equals I, where x can either be the square root of 2 over 2 plus the square root of 2 over 2i, or negative square root of 2 over 2 minus the square root of 2 over 2i. Thanks for watching.